Hi, welcome back to the Common Lisp series. So in this video, we're going to go in a different direction. So we're not going to follow the chain of thought that we had in the last few videos. We are going to here try to implement a very simple version of the core util find. So basically, not a full version like a CLI command, but just the core function and just play around. I know this is totally switching gears compared to the previous set of videos, but be assured we will come back to 2D animation and stuff down the line again. Uh, so today we will implement a very simple version of find. So we will just have finding a string. So let's not even go to regex. Let's just do simple string. Finding a string match in recursively in a given directory, right? So I'm going to start with the most basic simple outline. So the first problem is we need to be able to find files and list them. So to do that, we need to basically we need to use some command from the operating system, right? So when I search around, so the one option is to use basically this is not a thing that is unfortunately standardized across common Lisp implementations. So SBCL as a different library for POSIX compared to other implementations and so on. So we can use that SB POSIX, but I just ended up discovering this nice package called filesystem-utils, and I am going to use this. So this has a bunch of functions, but it also has the interesting directory walking functions that we wanted. So I just basically searched online and then hit upon this, and let's just use this, right? So if you see here, we do this quick load of file system utils, but we are doing something different here because we want to use the functions directly. I'm going to use the package, but if you see the name of the package, so just from this eye level index, you can see that the package name is this. It's not just file system util. So you have a system file system utils, and you have the package which is named slightly different. So we will go more into systems, ASDF, etc. later. But for now, you just need to set the name here to be right. And to start out, I am having a very simple find function template. So basically, I am taking a single argument, which is a match, and an optional argument for the directory, which is going to be the current directory, if nothing. So for now, I'm just printing out. So tilde a will just print out value default printout and a new line at the end. So we just start very simple. We have this to begin. So let's do it very simply. Let's first just get all of the files, right? Walk the entire directory, and then let's think about filtering stuff out, right? So I mean, very simple strategy. So when I was just browsing over this package, I could see that the thing I needed was this map function, map directory function. So basically, it's allowing you to run a function on every entry, either the file or directory of that directory. So let's try this. Let's use this and let's give it a shot. So I've taken a first stab at trying this. So I'm just using the map directory. And if you see the function signature here, we given a function that we want to run and for the top level directory, and then we ask it to run for every file and directory and recursively too, right? And the process entry function is going to just take the path and print the path. So simple. But if I do this, I am getting this error, which says that the path is not a directory, right? And this is likely to happen because we have just passed a string and not a real path. So let me check if this package has utilities for path manipulation, or we'll have to go back to some other package to do that portion. This page a bit, I did see this true name star, and that kind of points to true name, which makes me think that this is something that is already built in to Common Lisp. And sure enough, as I was playing around, that's what I saw. So what I mean is, so if you do true name of this, I get the full directory. If I do true name of something that, like, of this file that already exists. Then I also get the full path, and you see this is a path, not a string. So you converted a simple string into a path. And I also saw that basically just searching me led to this other things like basically the core package files related operations, which are like inbuilt into the standard library, I believe. And I see that I can use this thing also to get me what I was looking for, right? So all of this will do. But for now, there's a problem. Like you see here, I need to check if the directory is a real directory or if it's just a file. But we can add error handling and stuff later, right? So now let's, with this in mind, what I just need to do is I need to convert this into a call to directory and recompile this, and let's try RC. Fine, super, right? And what do we see now? We see that it is not of type string path name. In fact, it looks like it's a list. Let's see what happened. If I go back to this, I see that it's actually a list. So we need the first entry, this list. So let's do that. Okay, so now what I see is it's actually printing out. So because I didn't put in percentage, there was no new line. So let's compile this and run this. And we see that it has iterated to the files in this folder, and I have got 3 entries. There is no guarantee of order, and that's fine. But also, we have not really checked for recursive behavior. So why don't we do that now? So I'm going to go to our uh, folder and make a dummy directory and touch a few files, and let's make one more, and now let's get back here and let's try this again. And we see all the files in any order, but nevertheless all the files. So that's great. So right now we're just printing it. Instead, what we will do is we will collect this into a list to do further processing. So specifically, we want to search for substrings in that list, right? So that's what we'll do next. On second thought, we probably don't really need a list, right? I mean, we are not doing any further sub-processing like we might do if we were to do grep or something. We just, and we are not even going to do a very compute intensive process. We're just going to do a simple string search, which means I feel we can just put our match logic into process entry, and if and only if it matches, we simply print it out, and otherwise we just don't do anything, and that itself should actually be fine. So yeah, so let's do that. Let's not collect the intermediate results at all. So if we want to actually do that, we need some package to do our string search. Let's see. I went and did a quick search, and the first hit I had was this. So let's just try this. I'm not really sure if this is the best one. I don't even know if there is something built in or something. Let's just go with this, right? I mean, that's what a simple search returned. Again, this is a package that has been not touched in 8 years. Might be scary in some places, but that's okay in Common Lisp. So let's see. Let's try it. Let's see if it works. So what we want is, so there are a number of different functions here. We can go with a simple brute force. We're not worried about optimization or performance here. So what they're saying, asking us to do is to try this. So let's try it. Let's get this in. And if you see here, they say that it exports functions in this package, also nicknamed as SM, which means most likely SM colon syntax should work without having to use. So what I want to do is the string contains brute. So let's just try that. Okay, it's still downloading. It's pulling a lot of dependencies. It's a lot of packages, but okay, let's see. Let's install. So we need SM, right? and we'll have all of these functions. So let's try sin contains root, the simple thing. And you want the pattern. So the pattern, let's say, just do something like this and see if it works, right? Okay, it says 0. I don't know what that means. Maybe it's the position. So if I try something like, let's see if that works. Okay, so it seems to work. As long as it's not nil, we're good. So that's good enough for us, right? So that's great. We can use this. Again, I'm not worried about performance right here. So which means I just need to plop this in here, right? But we have a problem. You see that we have the path, but we don't actually have the match. So ideally we need to pass in that here, which means we can't just use process entry. We have to basically convert this into a function that takes 2 arguments. So let's do that. So I'm going to take the very simple approach. I'm going to like literally pass in the argument here, but then we can't use this function here. So instead what we'll do is we'll wrap this with a lambda. So we will take a single parameter, the path, and then we will call the path and the match. So we are basically taking the match from the surrounding context here, and we'll get p from whenever the function is called, right? So we have swapped out the process entry function for a lambda. There might be a better way to do this with currying. Let's see that later. So for now, we have converted this function which takes 2 arguments to this function which takes a single argument, and that will be the path, right? So let's evaluate this. I don't use this, so let's replace this with what we did earlier, which is sm, and what was it? I forget. String contains root, right? And so the search string is this and the path is this, and that should be it. And if it's true, we will format the path. We'll print the entire path if this is true. So that makes this done. And let's recompile this. We're good. And let's go back to our find, and let's see. There's nothing because there really is nothing. So let me try something else like IR, because I have different subdirectories. Okay, I managed to miss the new line here again. Okay, not bad. So we have the output now with the matches. Only the lines which match are shown, right? So that's great. So I thought of a few different directions we can go from here. For example, we can check performance for like a big data set and see if we should parallelize it. That's interesting, but I'm not going to do that today. We can also look at, say, colorizing the output. Also interesting, but let's again do that later. What I will instead do is talk more about currying, right? So I just spent a few minutes going through some stuff, and I think this is like a very nice place where we can talk about this. It's totally unrelated to our command, but let's just use the second part of the video to talk about this particular package that I found called curl, right? Let's take a step back and see what I'm talking about. So we saw here we had a function, and we wanted to really create another function where one of those arguments was already passed in, right? So what I mean is, if let's say you had a function add, or you know what, let's take subtract, so maybe it's a bit easier to explain what I'm saying. And here, let's say we subtract x and y, right? So this is a nice function. So you can use this function. So if I do subtract 10 and 5, you can basically use this function. If we go here, we can run, sorry, show you the subtract 10 pi, and you see the results, right? Or maybe if I make this 9, you see the results. That's great. But now what you want is, you actually want a function that takes a single argument and then call subtract with that argument and a fixed. So let's say we want to fix this argument 9, and the other argument is going to be passed. So this is basically a new function, right? And you want this function. Basically, you want to use this function for various reasons. You want subtract from 9 as a function, and then you can pass in various arguments, right? You don't want to, you want to create a new function, but doing this is like very verbose, isn't it? Like you need to write all this to achieve what you want. This is known as currying. This is very common in Haskell and other pure functional programming languages, but we can do that very well in Common Lisp because Common Lisp can do anything. So the thing I want to talk about today is curly. So I just discovered this like 5 minutes ago when I was trying to create this video. And so what is this? I just searched for packages, Common Lisp packages for currying, and I got this. And this is like 13 years ago, 18 years ago. But yeah, no worries. The README is a bit messy, but I could quick load it, so that's great. So it was there on quick lisp and I could pull it. So now again, the README is not exactly clear here, but with some trial and error, I can understand what's going on. So curly gives you a reader macro. So what is that? So that's again an advanced common Lisp concept, but anyway, let's talk about that today. So that means it's macros. We haven't even covered macros proper, right? But for the moment, reader macros are ways to change your actual parsing of your input. So for example, you already know that common Lisp has parenthesis as its main syntax element, but using reader macros, you can create new syntax elements. And if you see curly, so because I've already installed it, like if I hit autocomplete it, you will see it only as these set of functions, and there is an enable curly syntax and disable curly syntax functions. So let's call the, I already done this before, but let's do it again. So essentially this creates a new read table. So whatever you type now will include the new syntax that has come from this package. And what is its syntax? So apparently, according to the README, there is two new syntax. There is a square bracket macro and there is a curly bracket macro. So let's try the square bracket macro. So what this is saying is, so we have the subtract function from before. So now if I just do subtract this, right? So this is, let's call subtract 4. So what have we done? Subtract function takes two arguments, right? I am, first of all, I'm not even using parentheses, right? So that's like super weird. I'm using square brackets, which don't make sense in Common Lisp, but that's what this package is actually added to the read table. That means I can use square bracket now to do something. But what is that something? We see that subtract here is basically it's not calling it because it would have errored out, right? If I call subtract with 4, that would have just errored out because one argument is missing, correct? But that didn't happen with this, right? So instead what happened was it returned a lambda, and this is exactly currying. So basically it has taken that one argument. So this is a new function which I can call. So let's say I call this with the argument 1, right? And you see what is happening is it is doing 4 minus 1, which means this 4 is actually gone into the first argument, and then the rest of the arguments are open. So this returns a lambda, and then I can use this lambda like this. But we didn't want that, right? We wanted the reverse. I wanted to be able to lock in x to 9. So how do I do that, right? I can't do that here, but that's where what this readme says is you can use this blank argument, right? So if you see the curly blank argument variable, it's star, right? So that means, and this is super interesting. So what this has now created is it has curried the sub function where the first argument is open, is going to be passed in later, and the second argument y is logged into 4. So now 1 goes into this slot and it's 1 minus 4, so that's why it's minus 3. So if I go back to our original thing, then this is what I would have wanted to say, 9 minus 4. Very interesting, right? I mean, look, this, you have basically converted the complicated lambda syntax, so I could have done this instead, right? So this is what I should have done, which is this, and these two things are identical, right? What this package has done is given you a new reader macro to make writing these kind of things easier. So this square bracket is that's what the square bracket is doing. So in our case, I will remove all of this and go up here. So here, instead of all of this, instead of using lambda, I can simply use, let's look at this again. I need to pass in a lambda. So in that place, I just need to pass square bracket because I just want to create the lambda. And I have to pass process entry, right? Um, the P will come in later. So I will leave it open. And the match, we have the match right now. So this is supposed to be identical. So if I go back to, so you find, and I will search for whatever I was doing earlier, I will see the same results. There's no error, everything's working, and the syntax is like a lot more different, simpler looking. Now there is also, because this, see, you see, this is a variable, right? I can, let's first disable, let's go back to our enable line, right? Or you know what, let's try it without that. Let's try it directly. Let's take risks today. So knowing this is common Lisp, this might actually work. So what I want to do is I want to set the blank argument to be, okay, this is amount of truth. Let's see this. I want to set this to underscore, right? And the underscore character. And if I go back to this, does this work? Okay, so it says variable is unbound, so maybe I shouldn't have used the character and I should have just used the symbol. Sorry. So let's use the symbol instead. Yeah, that makes more sense. Great. It works. It's dynamic. See, this is at its essence the beauty of Common Lisp. You're changing the syntax of your language at runtime. I'm able to change how my language should look like in a very powerful way. And this is just a random package, right? So of course, this power is coming from reader macros. That's what they mentioned here. But that is the like true power of Common Lisp. There's also interestingly the curly bracket, which they're talking about function composition, right? I'm not fully sure what that is, so maybe let's try it out. So to play around with this curly bracket reader macro, let's create two functions which take single argument just for ease of use. So this is what I understand. So let's say a square function which simply squares the input value, and let's say an add 10 function uh, which is going to add maybe a safer name, right? Is going to add 10 to the value, right? So x and 10. Okay, so these functions are both taking single arguments. So if I want to call them one after the other, right? So if I need to do, let's say, square of 4, and then I want to add 10 to this, right? So that's okay, makes sense. Now, if I understand the curly bracket thingy, this should be equivalent of what we just did. Okay, so basically this is function composition. You are composing the two functions into a single function, which you can then call, right? And then of course the README has a little bit more examples of how to use it with partial application and so on. That's not important right now, but this is a very standard pure functional concept. This is something you see in Haskell. This is something you see in array programming languages like APL and so on, where you can compose functions. And the same thing we have here in smoother syntax. I believe you see this as a first class thing in Clojure also, but today we are just seeing how you can implement simpler syntax for the same thing in Common Lisp with the magic of reader macros. So to recap, this was maybe a weird video. I started out with trying to implement a simple version of find. My aim was to come up with a basic framework with which we can build other things like grep and maybe things like fuzzy find in future videos, because that would involve more things apart from just directory walking. But since we had the opportunity, we took a detour and went into this package called curly, which is showing off power of reader macros, and in this specifically for currying and composition, but reader macros can do a lot of things elsewhere also. Now, if you didn't understand reader macros, not to worry, we will obviously go into more details later. This is a very advanced concept. We have not even talked about macros, writing our own macros. So eventually we'll get to writing our own reader macros also, but hopefully this was a fun video. I didn't plan it to be like this, so I'm as pleasantly surprised, and I didn't know about this package and this thing, so I'm pleasantly surprised as you are, but this was a fun video. Okay, see you next time. Bye.